What's up everybody, welcome to another video. Hope you're ready to flex those brain muscles. In this video we're going to practice solving rational inequalities. I have a couple examples here. In total we're going to go through 3 examples. The video will be timestamped, so skip around. Use this as a resource for your learning. Try some of these on your own, compare your strategy with mine, check your answers, that sort of thing. Hopefully this helps. Let's jump into the first example here. Here's our first example. And with this first example, I'm going to give a little more detailed explanation for our strategy and why this strategy works. So hopefully you've solved polynomial inequalities before, and our strategy with those is to make a sign chart, right? We draw a number line, we plot all the zeros, we make a sign chart. We're going to have a very similar strategy here. The only difference is this time this is a rational function. It could have wholes, it could have asymptotes, right? It is not continuous. So let's look at an example here. And I'll start with this polynomial function. Notice that the polynomial is continuous, right? There's no wholes, there's no asymptotes, jumps, or anything. That means that in order for this to change from negative to positive or positive to negative, it has to cross through the x-axis, right? And so if we were trying to figure out when this expression here on the right is greater than or equal to 0, we can think about this graphically and think about that as what are all the x values that give us outputs that are above the x-axis. And we can see that those are all the x values from -2 to 3, and then from 5 all the way forever and ever to infinity, right? And so that would correspond to our sign chart that we made, and we write that as a solution using brackets if it were a greater than or equal to, right? And using parentheses if it were just greater than. So we have a similar idea when we have rationals here. The only difference is we have more ways for a function to change from positive to negative, right? Notice this. Yeah, we cross through here. The function's positive. It's above the x-axis. Then it's below. Then it's above again. But from here to here, it jumps, right? It jumps from positive, all the way up. It looks like x is getting closer and closer to -3, which makes sense since that's where our asymptote is at. And then it jumps down here below the x-axis, right, where all of these outputs are now less than 0. So we're making our sign chart, we're including zeros, right, x-intercepts, but we're also including asymptotes as well as wholes. We want to include all those things in our sign chart because those are all possible ways for the function to change signs from positive to negative. Additionally, you may think, well, sometimes we have wholes up here. What if there's a hole like up here? How does that affect our solution? Well, again, we still want to exclude any value that is a hole, right? Because when we're thinking about these inequalities algebraically, what we want to write is the solution set, the set of all possible numbers that we could plug into this inequality that would satisfy it, which means that would make this left-hand side, in fact, less than or equal to 0. If there's a hole, then that x value cannot be a part of the solution set because by definition, if we plug it in, we're going to get something undefined, 0 over 0. So we need to pay attention to wholes as well as asymptotes. All right, so let's start. We're going to factor this. We're going to factor the numerator and the denominator, which shouldn't be too bad since these are both trinomials where a equals 1. So I'm going to go through it pretty quickly because I hope you know how to do this by now. We have x minus 5 times x plus 2 on the numerator. And again, we're looking for two numbers that multiply together to give us -10, but add together to be -3. And that -5 and 2 work. And the denominator here, we're going to have x, what is it going to be, minus 6 plus 1. And so what do we have here? We have 2 zeros or x-intercepts, right? So again, to find those x-intercepts, we're looking at the numerator. We're looking for values that make the numerator 0, but do not also make the denominator 0, which is both of these values 5 and -2, because neither of these factors are also present in the denominator. So these each correspond to an x-intercept or a 0, and so I'm going to use a filled-in hole at -2 and at +5. So we're going to do a filled-in hole here at -2 and one up here at +5. All right, now what do we have in the denominator? These are each asymptotes. These are vertical asymptotes at, let's see, x equals 6 and x equals -1. So for asymptotes as well as wholes, any kind of discontinuity, I'm going to use an open circle because, again, we do not want to include these values in our solution set because they give us something that's undefined and not something that's less than or equal to 0. So I want to exclude those as well. So -1 is here. We're going to exclude that, and we're going to exclude 6 as well. So now we're ready to make our sign chart. We can think of this number line as being split into sections. We have one section here to the left of -2. We have one here between -2 and -1, between -1 and 5, between 5 and 6, and from 6 all the way to infinity. Okay, so we have 1, 2, 3, 4, 5 different sections. We have to figure out, is the function output positive or negative in each of these sections. So we can pick test values, test points. And I'm going to write this out formally. You don't necessarily have to do this, but I like to do this. And I'm just going to pick a number that is within each of these sections, right? So to the left of -2, I'm going to pick -3. Between -2 and -1, it's kind of tough. It's going to have to be a decimal. I'm going to pick -1.5. In here, I'm going to pick 0. In here, again, I have to pick a decimal. That's 5.5. And then past here, I can pick 7. And for each of these points, I just want to figure out, if we plug this in, do we get something that's positive or negative? And that's going to give us the sign for the outputs for that entire section. All right, so for example, with -3, I'm going to plug this into the function, and I always plug it into the factored form because it's just easier to figure out whether the output's positive or negative. So I'm going to write the sign for each of the factors. So for example, when I plug -3 into this factor here, x minus 5, I get a negative. So I'm just going to write minus there because we're not interested in the exact number we get. We don't need that. We just need to know whether it's positive or negative. -3 plus 2, that's a negative as well. -3 minus 6, that's a negative as well. -3 plus 1, that's -2. We have 1, 2, 3, 4 negatives in this expression. Whenever we have an even number of negatives, the result is going to be positive. When we have an odd number of negatives, the result's going to be negative. So our final answer for this is that we are positive in this section, and I'm going to write a big plus here. Positive in that section, okay? Hopefully that makes sense. Let's try plugging in our next test point, -1.5. We get a negative times a positive, positive 1/2, right? Times a negative times another negative, -1/2. So now we have 1, 2, 3 negatives. So the final output is going to be negative, and we're going to write a negative in this section here, okay? All right, now let's try 0. Plugging in 0, I get -5 times +2 over 0 minus 6, that's -6 times +1. Again, I have a negative times a positive, that's going to be a negative. This is going to be a negative, and a negative divided by a negative is a positive, right? Anytime we have an even number, it's positive. So 5.5, let's do our next section. Plugging in 5.5 minus 5, that's a positive, times 5.5 plus 2, that's also a positive. 5.5 minus 6 is a negative. 5.5 plus 1 is a positive. We have one negative here, so our final result is that this section has a negative output. So the graph is below the x-axis between 5 and 6. All right, now let's plug in 7. 7 minus 2, sorry, 7 minus 5 is 2, that's positive, positive. I think these are all going to be positive. 7 minus 6, positive, positive. So we have a plus here. I forgot to write these. Awesome, but again, we're really looking at our sign chart here, not our test points. We just use these test points to finish our sign chart, but now we have our completed sign chart here, and we can get our solution set from this sign chart. So over here in this corner, I'm going to write our final solution. We're going to write it in interval notation. We may have unions, right, connecting more than one interval. And so let's look at what we're looking for here. When is this less than or equal to 0? Okay, so on or below the x-axis. And since we have less than or equal to, we're going to want to include a bracket whenever the function is equal to 0, right? Whenever it is intersecting the x-axis. So from -2 to -1, I see that this function is below. And it's actually on the x-axis at -2, but it never touches the x-axis at -1. In fact, this is an asymptote, right? This is a dotted line. So the easiest way to think about this is whenever we have these open holes, they are going to correspond to a parenthesis. And whenever we have these closed circles, they are going to correspond to a bracket, right? As long as our inequality here is a less than or equal to or greater than or equal to. If it's just a strict inequality, less than or greater than, then everything's going to be parentheses, right? So in this case, our final solution set, right? The first interval is from -2 to -1, and we use a parenthesis on -1 because there's an asymptote there. The function is undefined at -1, so we don't want to include that as a solution. Then we want to pick back up, so we write union. We want to start back up from 5 to 6, and this time we want to include 5, but exclude 6, so we're going to use a parenthesis there. And if you take this function, right, f of x equals this thing, punch it into decimals, you should be able to confirm this, that it intersects here, goes below, it approaches this asymptote, and it does a similar thing. It goes here, goes below, approaches that asymptote, right? Awesome. Hopefully this process makes sense. Let's try our next example. Same idea. First thing we're going to want to do is factor both the numerator and the denominator. So let's start. In the numerator, we have a trinomial where a equals 1. So I'm looking for two numbers that multiply together to -5 and add together to -4. That should be x minus 5 and x plus 1, -5 and +1. In the denominator, I have a difference of squares. So we're going to have x minus 3 times x plus 3. That's a difference of squares. All right, I'm going to do my number line. I believe I did it in blue, so let's be consistent. I'll do it in blue. And let's see, what do I have here? I have two asymptotes and I have two x-intercepts. There are no holes because there are no factors that are present in both the numerator and the denominator. So for my x-intercepts, on my sign chart, I'm going to do filled in circles, so I'll use red again. And I'm going to do one at 5, filled in circle at 5, and I'm going to do one at -1, filled in circle at -1. I'm going to have open holes at 3 and -3. So I'm going to do an open circle here at 3 and an open circle here at -3. And now I can find test points. So down here in purple, I'm going to do test points. So a test point for this section from -3 to the left can be something like -4. For this section between -3 and -1, I can plug in -2. For here, I can plug in 0 for that section between -1 and 3. In here, I can plug in 4. And for 5 to the right, I can plug in 6. And now for each of these numbers, I'm just trying to figure out, do they correspond to positive or negative outputs? So let's start with -4 here. And again, I'm always plugging into factored form, just makes our life a lot easier. And I'm going to actually write out each factor, whether it's positive or negative. So -4 minus 5 is negative. -4 plus 1 is negative. -4 minus 3 is negative. And -4 plus 3 is also negative. Right, so we have 4 negatives total. So that means our final output is positive. And I can write a plus in this section. Now let's try -2. We get -2 minus 5, that is a negative, times -2 plus 1, that's a negative, -2 minus 3, that's a negative, and -2 plus 3, that's a positive. So now we have 3 negatives, so this final output is negative. Now we can plug in 0. When I plug in 0, I get 0 minus 5, that's a negative, times 0 plus 1, that's a positive, times 0 minus 3, that's a negative, times 0 plus 3, that's a positive. 2 negatives make a positive, so our final output is positive, and we are above the x-axis in this section. Now let's try 4. We can plug in 4. What do we get? 4 minus 5, that's a -1. 4 plus 1, that's a positive. 4 minus 3, that's a positive, it's +1. And 4 plus 3, that's also positive. So we have 1 negative, which means our final output is going to be negative, and we are negative in this section. And now we can try finally plugging in 6. 6 minus 5 is positive. 6 plus 1 is positive. 6 minus 3 is positive. 6 plus 3 is positive. We have 4 positives. Everything's positive. So we are positive in this section. And since we want to figure out when this is greater than or equal to 0, we are looking for our pluses. To the left of -3, between -1 and 3, and to the right of 5. And since it is greater than or equal to, we want to include any closed circle that is on the edge of one of those sections. So let's write out our final solution set. It's going to contain 3 intervals. Hopefully you can see that because we have 3 pluses. So let's write solution set. And so our first interval is from -infinity all the way up until -3. And we use a parenthesis here because we have an open circle, right? This corresponds to a vertical asymptote. So parenthesis. Union. What do we do next? Well, plus from -1 to 3. And at -1, we have that closed circle. So we want to use a bracket here. We're going to write -1. And we want to go all the way to 3 and then use a parenthesis because we have an open circle at 3. Union. All right, then we want to do this final section for 5 to infinity, and we want to include 5 because 5 is a closed circle. It is an x-intercept. And go all the way to infinity. And for infinity and negative infinity, we always use parentheses because those are not numbers that can be included, right? Negative infinity and infinity are not numbers. So this is our final solution set. This is a bracket. I know it looks a little ugly. That's a bracket. Hopefully this makes sense. For this last example here, this is the last example we'll do. Pause the video, try this on your own. Pull out a piece of paper, see if you can do it. We're going to start by factoring. So I'm going to start by factoring this expression. These are both trinomials. I think we've done this trinomial in the numerator in this video previously. We have x minus 3 times x, let's see, plus 2. Is that right? Minus 3, positive 2, that's negative 6. They add together to negative 1. Looks good to me. In the denominator, let's see, minus 2. So we're going to have plus 2 minus 1. Let's double check that. Plus 2 minus 1. Those multiply together to negative 2, add together to positive 1. Amazing. So now you can notice this is our first example where we do have a hole. We have a hole at negative 2. So that's going to show up on our number line. Let's write out our number line here. So our sign chart, we're going to have a hole at negative 2. So that's going to show up as an open circle at negative 2. We are going to have another open circle at 1 because that's an asymptote. And then we're going to have a filled in circle at 3 because that's an x-intercept. So here I'll make this 3. That's an x-intercept. We have an open circle at 1 because that's a vertical asymptote. And then we have another open circle at negative 2 because that's a hole. All right, now here's a trick. We're going to make our test points. And actually a couple of my students pointed this out to me, and it makes total sense. I love this. So we're going to do our test points. We have a negative 3 that we can plug in this section. In here we have 0. In here we have 2. And here we have 4. And we're going to plug each of these in, but notice that when I plug these in, I can ignore the x plus 2 over x plus 2 factors, right? I can ignore both of these. And why is that? Well, because whatever number I plug in, I'm going to get the same output for both of these factors. They're going to either both be positive or both be negative, which means I can ignore them and it won't affect the sign of x minus 3 over x minus 1, right? The sign will be the same whether I plug in negative 3 to both these factors and include them or whether I ignore it, because the sign of two factors that are the same is always the same. Hopefully that makes sense. We get 2 positive or 2 negatives, and either way they cancel out. Hopefully that makes sense. All right, so I'm going to ignore that. I'm just going to do 2 factors for each of these, make our life a little bit easier. So plugging in negative 3, what do I get? Negative 3 minus 3 is a negative, divided by negative 3 minus 1 is a negative, so we are positive in that section there. Now I can plug in 0. 0 minus 3 is a negative, over 0 minus 1, that's a negative. So I'm also positive here. And you're thinking, wait a minute, on all the circles previously we've like alternated. Well, yeah, that's because this is a hole, right? So we're above the x-axis, we have a hole, and then we continue being above the x-axis graphically. That's what this looks like. All right, let's plug in 2. Figure this section out. 2 minus 3 is negative 1 over 2 minus 1. That's positive 1. Negative over a positive is negative, so we are below the x-axis here. And now we can plug in 4. 4 minus 3 is positive, 4 minus 1 is positive, so we're above here. And so for our final solution set, we want to figure out where this is bigger than or equal to 0. So we're looking for pluses. And again, since we have or equal to, anytime we have a filled in circle, we want to include that using a bracket. So for our final solution set, writing it using interval notation, we're starting from negative infinity, going all the way to negative 2. And we use a parenthesis there. We want to skip over negative 2 and continue all the way up until positive 1. And use another parenthesis there because that's an open circle. And finally, we want to include 3 all the way to infinity, and this time we want to include 3 in our solution set because there's a filled in circle there. Awesome. Hopefully this video helps make sense. Leave any questions below and keep flexing those brain muscles. I'll see y'all next time.